Welcome to Cookies, Maths and Science Hub. Today we're going to be discussing the concept of the mole and what we mean by molar mass. When you've discussed an atom in the past, you've been told how small it is. The mole is a concept that has been developed to help us count and have a set number of these atoms. Think about when you go get eggs from the shop. You get a dozen eggs. We know the number dozen represents 12. The mole is similar in nature in that the term mole represents a certain number of things. So, much like in our example where a dozen is 12, a mole is defined as the amount of substance that contains as many particles, whether they are atoms, ions, or molecules, as there are atoms in exactly 12 grams of the carbon-12 isotope. That means it is all based around the mass of that carbon-12 isotope. The number of carbon atoms in this 12 grams has been experimentally estimated to be 6.02 times 10 to the 23 atoms. This number, 6.02 times 10 to the 23, is called Avogadro's number. Now, remembering our scientific notation, that means if we were to write this number out in full, we would have 602, 000, 000, 000, 000, 000, 000, 000, 000, meaning it is a very large number. Whilst a dozen eggs might be enough to feed you and your family for a week, if you had 1 mole of eggs, then I think you and your family would have enough eggs for, well, a very long period of time. The mole has many uses in chemistry and will be used throughout much of your studies moving forward into more complex chemistry. Looking at a brief example below of how it might be used in discussion, let's look at a chemical reaction. In this reaction, we have sodium hydroxide reacting with sulfuric acid to produce sodium sulfate and water. The coefficients in reactions can represent the number of moles. So we would have 2 moles of sodium hydroxide reacting with 1 mole of sulfuric acid. This would then produce 1 mole of sodium sulfate and 2 moles of water. In these scenarios, of course, it's important to have the balanced chemical equation. Let's look a bit further into how we can use the mole and discuss the concept of molar mass. So, we know that 1 mole is 6.02 times 10 to the 23, and that this is based off 12 grams of the carbon-12 isotope. When we discuss molar mass, the molar mass, represented by the letter M, of an element is defined as the mass of 1 mole of that element, meaning it is the mass of 6.02 times 10 to the 23 atoms of that specific element. In chemistry, we measure mass in grams, meaning the unit for molar mass is grams per mole. Looking at a basic example, the molar mass of carbon atoms, that is, the carbon-12 isotope, is the mass of 1 mole of those carbon atoms. From our original example, when we talked about the mole, we know that that is 12 grams. Therefore, the mass of 1 mole of carbon atoms is 12 grams per mole, and that is our molar mass of carbon. For our ongoing calculations, we can find the molar mass of any element on the periodic table, as the molar mass of any element is equal to its relative atomic mass. We know that 1 mole of an element has a mass represented by its molar mass, which is represented by the capital letter M. And we know that mass of a substance can be represented by the lowercase m, we can represent the number of moles as n and create a formula to solve for unknowns in different situations. This formula is n, being our number of moles, is equal to lowercase m, being our mass in grams, over uppercase M, being our molar mass in the units grams per mole. This allows us to solve for situations where we have multiple moles of a substance, or we are trying to find the mass of a substance and know its molar mass and number of moles, or perhaps we are trying to find the molar mass of a substance and we know its number of moles and mass. Okay, we have two example problems to work through now. Let's start with the first one. We have 32 grams of sodium, and the question is asking us how many moles of sodium are present. Looking at our formula, our number of moles is equal to our mass over our molar mass. So in this case, N is going to be equal to 32 over 22.99. Remembering, we can get our molar masses of specific elements off the periodic table. This is equal to 1.39 moles. Therefore, 1.39 moles of sodium are present. It's always good in these kinds of questions, and any science question really, to justify your answer after you've done your calculations, as is done in this example. Looking at our second example now, in this one, we've been given the number of moles of water remaining in our drink bottle and asked to calculate the mass. Looking once more at our formula, N, our number of moles, is equal to our mass over the molar mass. As we want to find mass, we'll need to perform a simple rearrangement of this formula. So we get mass is equal to our number of moles multiplied by our molar mass. Then we'll get mass is equal to 6, our number of moles. However, in this case, because it is a compound, we need to add the molar mass of 2 hydrogens and 1 oxygen together, as water is H2O, 2 hydrogens, 1 oxygen. So we get mass is equal to 6 times 1.008 times 2 plus 16, which gives us mass is equal to 6 times 18.008. Then our mass is equal to 108.05 grams. Once again, it's good to finish with a statement. So in this case, therefore, 108.05 grams of water remaining. Thanks for watching. Hopefully now you can easily define what the mole is and what it represents, and what we mean by molar mass of an element. Hope to see you again soon.